Here we go. So notes 23, intro to double. So first a quick recap of what we did yesterday. That way you can make sure that you are super solid. Not everyone has taken care of that delta, guys. There's a couple of you that didn't finish. There's a couple of you that only did like 2 questions and then just stopped. Like, guys, come on, keep going. So here we go with this. Cosine x minus y. And obviously, the way this is formatted, it looks like it's coming from UH. So it is. Let's give them credit. So I'm going to write UH there. So cosine x minus y. Do we know the composite argument property for that?
Yes.
Yeah. Cosine x, good job. Cosine y plus or minus? Plus sine x sine y. Now, in case you're wondering, like Chavez, Delta Math didn't call it composite argument properties. Delta Math called it angle sum difference, angle sums and angle differences. If you Google that, that's the same. It's angle sums and angle differences. Why do they call it that? Because those are angles right there that they're subtracting. Angle difference. All right, anyways, so here we go. This angle is in quadrant 1. Because they tell you there, x is between 0 and 90. So exaggerate quadrant 1. Here's me exaggerating quadrant 1. Here's angle x. And then they tell me that sine is 2 over 5. So sine is opposite over hypotenuse. Opposite, hypotenuse. How do we feel? The hypotenuse is the longest side. So because I have the longest side present, you're going to subtract to find this side, the missing side. Does that make sense? So I know that's been an issue because sometimes they're like, well, I don't know if I should add or subtract. If they give you the hypotenuse and you're looking for a missing side, you're going to subtract. What's 5 squared? 25. What's 2 squared? So the square root of 25 minus 4, leave it as square root of 21. Let's see, 7, 3. Nope, doesn't break down. Leave it alone. Cool? All right, so from that one, we're going to get cosine x. I'll write cosine x here on the side. Cosine x is square root of 21 over 5. All right, now I'm going to do this one in blue. 180 degrees to 270. That's where angle y is. So what quadrant is that? Quadrant what? 3. So I exaggerate quadrant 3. Here is my right triangle. And I use my reference to help me out. So there's my angle y. The real angle y is this one. So don't write this down. Just that one in green is the real angle y. But we always use a reference to help us out. That makes sense, guys? All right. So they tell us that sine y is negative 1 over 3. So negative 1 and 3. The hypotenuse is never negative. The hypotenuse acts like a radius. So the hypotenuse is never negative. Are we okay with that? All right. I got my hypotenuse, so that means I'm going to subtract the square root of 3 squared minus negative 1 squared. 3 squared is, and 1 squared is, and 9 minus 1. So square root of 8, put a negative in the front because you're in quadrant 3. Now square root of 8 can also be written as negative 2 square root of 2. Are we okay? Let's see, they give me sine y, so I'm going to need cosine y. Cosine y is going to be negative 2 square root of 2 over 3. Are we ready? I feel like, I feel like we're in a basketball game. Like, are you ready? Like, okay, I'll stop, guys. Also, they do it in wrestling. Do you guys remember a name called, I think his name was like Michael Buffer or something? And he was like, are you ready for the millions of fans standing? Okay, you know what? Let's just stick to math here, guys. Sorry about that. Cosine x, do they give me that? Nope, but I have it over here. So square root of 21 over 5, close, open. And then cosine y, I have it over here. Negative 2 square root of 2 over 3, close, plus sine x, and that they give me 2/5. And then sine y. Sine y is negative 1/3. There it is. And that's it, guys. We're done. So let's see. Negative 2 square root of 42. Whenever you have square roots, that's really like law of exponents. You can just multiply the 21 and 2 because they're inside the quote-unquote radical. Over 15 plus, that's a 15. It just came out weird there. Positive times a negative is a negative, so minus 2 over 15. And I don't see anything reducing, so I'm going to write negative 2 square root of 42 minus 2. All this is over 15. And then we look for that answer. Is that answer in there somewhere? Yeah. Letra A. That's how you say A. A. Letra. Okay. How do we feel? All right. We're going to derive sine 2a and cosine 2a and eventually tan 2a way down here. Do you guys like it when we derive equations or no? Or you guys just want to be told the equation? Don't you want to know where it comes from? All right. Don't worry. You're not going to have to derive it yourself unless, maybe we'll ask a bonus question. All right. What are we going to need? We're going to need sine a plus b. So at the very top, write what the sine a plus b is. Sine a cosine b plus or minus. Plus cosine a sine b. The sine keeps the sign and toggles. Sine, cosine, cosine, sine. And I'm also going to need cosine a plus b. What's this one? Cosine a. Oh man, help me out guys. Cosine b plus or minus? Minus sine a sine b. And eventually we're going to need tan as well, but we'll get to that one when we get to that one. Y'all ready? Here we go. Sine 2a. We're going to do a hack. I'm going to write sine 2a is the same thing as saying sine a plus a. Do you see the hack that we're using? I'm using the hack of calling this b up here an a. So then anywhere I see the argument b, I'm going to change it to a. So I'm going to write sine a cosine a plus cosine a sine a. Is anyone offended? Oh man, don't be offended. Huh? Why didn't I what? No, say it. I didn't hear you, miss. Oh, I can. Yeah, I'm gonna write it once right now. Are we okay with that, guys? Now, sine a times cosine a is the same thing as cosine a times a. How many of them do you see? So here is your new double angle formula. Sine 2a is nothing more than 2 sine a cosine a. There it is. You just derived it. This one only has 1. How do we feel? Not bad, right? Pretty cool? I think it's pretty cool, guys. All right, let's go to the next one. What about cosine 2a? Well, let's do a hack. Cosine a plus, well, I guess first let me write cosine 2a. Cosine 2a is the same thing as saying cosine a plus a. Yay or nay? Yay. All right, it's all goodness. So I'm just going to use the top argument. I can see it at the very top. I'm going to replace the b's with a's. Cosine a minus sine a sine a. How do we feel about that? No one's offended? All right, here's our first formula. So that means cosine 2a is the same thing as saying cosine squared a minus sine squared a. That's our first one. This one has 3. I'm going to do a side note. I'm going to change the colors. Can I move this or not? So here we go. I'm going to change the colors. I'm going to go side note. And I'm going to write the Valentine's formula because it's almost here. Cosine squared a plus sine squared a equals 1. Right? So from there, I can do 2 substitutions. One substitution, I can go cosine squared a is equal to 1 minus sine squared a. Or another one is sine squared a is equal to 1 minus cosine squared a. I'm going to use both. But first, I'm going to do one of them first. All right, so let's do the first arrow. Let's replace the cosine squared with 1 minus sine squared. So this cosine squared that I see here, I'm going to replace it. So here it is. Cosine 2a is equal to parenthesis 1 minus sine squared a minus sine squared a. Are we still okay? Okay. So then I'm going to drop the parentheses. 1 minus sine squared a. I just dropped it because it was hot. No, that was stupid. We were actually having a discussion, I think yesterday. I think it was yesterday, maybe it was 2 days ago. Like when Snoop Dogg wrote that drop it like it's hot, was he like holding coffee and then he's like, oh, it's hot. And then he dropped it. And then that's when he came up with that genius lyric, drop it like it's hot, drop it like. Okay, I'll stop. Let's just do math here. I'm sorry, guys. All right, how many sine squares do you see? 2. So here's their second equation. Cosine 2a equals 1 minus sine 1 minus 2 sine squared a. There's my second one. Yay or nay? All right, there's one more, and I should have put more space in there, darn it. I'll write it over here. You want me to switch colors, guys? For the third one? All right, one more. Instead of replacing the cosine squared, I'm going to replace the what? The sine squared. So here I am. So I'm going to write it in green, guys, just so we can differentiate the third equation. So I'm going to write cosine 2a is equal to cosine squared a minus, and I'm replacing what sine squared is, open parenthesis, 1 minus cosine squared a. I'm using this one right here. When I do that, this time I do have something in front of the parentheses, so I can't just drop it, I have to distribute. So I have cosine 2a is equal to cosine squared a minus 1 plus cosine squared a. How many cosine squares do you see? 2 of them. So here's my formula, my third one. Cosine 2a is equal to 2 cosine squared a minus 1. There's your third one, guys. Oh. This is going to be funny. You guys are going to laugh. I don't know, maybe not. You see and I typed these notes out. I can't believe my short-term memory is that bad. You see where it says, can cosine 2a be defined with different expressions? I was supposed to, right?
Mr. Chavez,
Yes, ma'am.
can you pause first period attendance?
Yes, ma'am, I will.
Thank you, sir.
I was supposed to do all these notes down there.
I was gonna say, I don't.
Yeah. Heck yeah, I can. All right, no worry. We'll make it look genius. We'll put little bullets. My first formula is cosine 2a is equal to cosine squared a minus sine squared a. My second equation is cosine 2a is equal to 1 minus 2 sine squared a. And my third equation is equal to 2 cosine squared a minus 1. How do we feel? Let me take attendance. So if you just bear with me here really quick. I don't even know what the website is.
It's like, I've never taken attendance.
Let me pause this. Here we go. I just took attendance because they beeped on me. All right, guys, let's continue. I continued the recording, and we are now recording. All right. Were you guys ready for the next one?
Yeah.
All right. It says now we will derive tan 2a. So you guys tell me, what was tan a plus b? Tan a plus
Tan A plus A over 1 minus tan A plus tan B.
Was that hard to remember?
No, I can remember these.
Yeah. So here's our hack. You see that B? I'm going to turn that into a A. So if I turn that B into an A, let's see what that gives us. So tan A plus A, now that's going to be tan 2A. So tan 2A is going to be, what is tan A plus tan A? 2 tan A. And then over 1 minus, what is tan A times tan A? OMG, look at this, guys. You guys just derived another one.
Can someone explain to me why we changed the B to an A?
Go for it.
So we're using tan 2A at the top. So that means tan A plus A, so there's 2 A's. So instead of the original formula being A plus B, we changed these to A's.
which allowed us to,
Derive.
there you go. It's like a hack. Good job. Now check it out. You guys should be proud. Look at the next page. Check it out, Ms. McLaren. We just derived all these equations by hand. All of them. And here's all the calculations that these guys did. They were the ones that were telling me what to do. So you guys should be proud. You guys just derived these equations, guys. So never should I hear, like, where do these equations come from? I don't know what I'm doing. I'm just plugging in and chugging. You guys want to see something cool? Wow, I think it's cool. I think you guys will like it. So check it out. You guys, look at question example 2. And I hope that you really, really start to love it. So question example 2 says, if cosine x equals 0.3, find the exact value of cosine 2x. Check your answer numerically by finding the value of x, doubling it, and finding the cosine. All right, don't worry about that. Look at this part. Let's do this first. You see how you have cosine x equals 0.3? So I am tempted to use one of these 3 formulas. Which one do you think I should use? The second one. Why? Perfect, because I already have cosine. So if you already have cosine, you're not going to bother with the top one because that says sine squared. And you're not going to bother with the bottom one because there's no cosine on that one. Does that make sense to you guys? So check this out. This is going to be beautiful right here. So I'm going to write cosine 2x. I'm just writing right now the expression. Equals 2 cosine squared x minus 1. Are we still okay so far? So now I'm going to rewrite it. They told me that cosine x is 0.3. So I'm going to go, I guess I'll put it here on the side. Cosine x equals 0.3. Now, I don't want you guys to be confused. So I'm going to write this here real quick. This squared means this. It means 2 cosine x, close it, squared minus 1. Does that make sense? All right. What is cosine x? The number? 0.3. Cosine 2x equals 2 times 0.3 squared minus 1. Are we still okay? What is 0.3 squared? Not 0.9, 0.09. And look, you're doing all this without a calculator. This is going to be awesome. You're going to see right now. If I double 0.09, what am I going to have? 0.18. And then I think we can do this without a calculator. What is 0.18 minus 1? Negative 0.82. We can do that without a calculator, right? All right, check this out. You're going to be mind blown. Well, I haven't done it, but I'm 99.9999% sure it's going to work because I typed out this question. So, you guys ready? I'm going to find the angle x with a calculator. I'm going to double it, and then I'm going to push cosine 2 of that angle and see if I get negative 0.82. So look at this. Look how awesome this is. Watch it not work. That would suck, right? Here's my calculator. And come on, buddy. Go, go, go. All right, here it is. And it doesn't matter. Do you guys want to see the angle? Like, do you guys want me to put it to degree so you guys can see it? Okay. So mode, let me put it to degree so you guys can see it. It doesn't matter what we're at, radian or degree. It's still going to work. All right, so check it out. I want to find out what the angle is. So it says cosine x equals 0.3. So to figure out what the angle is, don't I do arc cosine of 0.3? So enter. Here's my angle, 72.54 degrees. I'm going to store it because I want it to be perfect. So I'm going to store it. Store it, and I like to just go down the alphabet. Well, by coincidence, it's angle way. Are we okay so far? Now check this out. I'm going to push cosine, and I'm going to push 2a. So what it's telling me is whatever that angle is, 72.54239688 degrees, double it. So I'm doubling it, and when I push enter, do you think it's going to give me that negative 0.83?
Yes.
It better, yeah. It better. Or A2, yeah. Look at that. Negative 0.82. Wasn't that cool, guys? You guys don't think that was cool? So I want you guys to see the beauty of math. Look how beautiful all this is. It just works every time, all the time. Now I feel like there's a line.
You use the other side of the equation, right?
Yeah, I used the
I didn't understand for a second.
So what do you think? All right. Here we go. Chavez, how is it going to look? How is it going to look on UH? We're almost there, guys, by the way. We are almost there to tackle the UH quiz. We still need a little more. We need half angles. And TBH, you actually already know half angles. You just don't know that you know it. Chavez, what do you mean? Okay, look, here's a quick hack. Do you agree that A is half of 2A? So you can already see the hack that we're going to be doing the next time we meet? Yeah, you already know it. You just don't know that you know it. Anyways, let's do this real quick. So example 3. Cosecant is -6 and angle X is between 270 and 360. At the moment, it's not important where it is. It is going to be important for half angles. But for double angles, you don't care. Where is cosine 2x? So here, or what is cosine 2x? So here we go. You guys ready? Cosecant is the reciprocal of which one? Sine. So I'm going to write, the first thing I'm going to do is I'm going to write sine x equals a -1/6. Are we okay with that statement? Next, I need to pick a formula for cosine 2x. So let me go to my formulas. Which one am I going to use for cosine 2x? The top one, the middle one, or the bottom one? The bottom one, because that's the one that only has sine. Does that make sense? So I bet you we can do this one without a calculator again. So I'm going to write cosine 2x is equal to 1 minus 2 sine squared x. Now again, what does that mean? 1 minus 2 parentheses, sine x, close it, squared. That's what it means. Are we still okay? Here we go. 1 minus 2, open parentheses, sine x is just -1/6, square it. Because I'm squaring it, that negative is going to go away. 1 minus 2, parentheses, 1 times 1 is 1. 6 times 6 is? How many times does 2 go into 36? 1 minus 1 over 18. All I did was 2 goes into 36 18 times. Are we still okay? Okay, Chavez, now I'm going to need a calculator. No, you don't. That 1, because it's a 1, I can make it whatever I want. That 1 is the same thing as saying 18 over 18. Is it not? Yeah, it is. 18 over 18 is 1, guys. It's like a hack. There it is, my common denominators. What's 18 minus 1? So this answer is 17 over 18. Look for that. Is it in there? And now you know how, when you took those UH quiz this past Saturday, how all those people are doing these questions really fast. They're just doing that, just really quick. How do you feel? Do we feel okay? Okay. And then the bottom questions, I guess they're not extremely important, but I guess let's just do it just so we can, just so we can be done. Write an equation expressing cosine 10x in terms of sine 5x. Okay, so do you agree that 10x is double the 5x? Yeah. So that's what I'm going to do. I'm going to write cosine 10x is the same thing as just double, so 2 times 5x. Are we okay? Bless you. And then there's that last formula. Chavez, what formula are you talking about? I'm using this one again because I want to see sine. So I'm going to write 1 minus 2 sine squared 5x. Done. That's it. That's all they wanted. So they saw cosine 10x in terms of sine 5x. There it is. I know, it's not that exciting. I probably should have deleted that one. How do we feel? Don't worry, I probably won't ask you this question on the exam. All right, here we go on the next one. Write the equation example 5 directly from the composite argument property for cosine. So that means I want to get to this, but do it from scratch. So let's see. Cosine 10x is the same thing as saying cosine 5x plus 5x, is it not? And hopefully you can already see what I'm doing. That 5x is like A, and the other 5x is like B, and I'm going to expand the cosine argument. Does that make sense, guys? So I'm going to write cosine 5x, that's an ugly 5, cosine 5x, plus or minus sine 5x, sine 5x. Because the arguments are the same, I can say this is cosine squared 5x minus sine squared 5x. Are you guys still okay? I do a side note. Side note. Cosine squared 5x plus sine squared 5x equals 1. You guys remember that? I'm going to substitute the cosine squared because I just want to see sine squares. So cosine squared 5x is equal to 1 minus sine squared 5x. That's what I'm going to substitute. I underline. So here we go. And I should put an equal sign on all these. So parenthesis, 1 minus sine squared 5x, close it, minus sine squared 5x. Then we're going to do what Snoop Dogg says, drop the parentheses, and we're going to write 1 minus sine squared 5x minus sine squared 5x. And then how many of these do I have? So my final answer, 1 minus 2 sine squared 5x, which is what I had for answer the one before. How do we feel, guys? All right, so today you just have a Delta Math. We've been keeping it easy this week. So log into Delta Math, take care of the double. If you haven't taken care of the original one, the sum difference, take care of that one too. So hint, hint, some of you. But we're going to take care of it though,
I
right?
was lying in the car and crying.
So that's it, guys.